Welcome to Get Your FRQ On. This question is from 2007. It's question 1, and it is calculator active. In the question stem, we're given two functions, and in part A, we are asked to find the area of the region bounded by those two functions. Now, in order to calculate this area, we do need to know the bounds of integration. They are not provided. But since this is a calculator active question, we can use our calculator to determine where those bounds of integration would have to be, and to do that we just need to know where those two functions will intersect one another. Right, so our two functions are y equals 2 and y equals 20 over 1 plus x squared. Right, now it turns out that the solution for the point of intersection here is actually pretty easy. If you set this up and do it algebraically, you do get nice solutions, but you might not know that going into it. So I might still recommend finding those points of intersection using your graphing calculator. All right, so it turns out the two x values where the functions intersect are at x equals plus and minus 3. So our bounds of integration are negative 3 and positive 3. All right, we can also tell based on the graph, or if you want to do this analytically, if you plug in 0 for x, 20 over 1 plus 0 squared is bigger than 2. So we can assume that the function y equals 20 over 1 plus x squared is actually the function that is on top. This is going to come in handy in a little bit. So the area of that region R is going to be the integral from negative 3 to 3. Those are the bounds that we found. Since 20 over 1 plus x squared is the one on top, we're going to take that first and then subtract the second one. And it turns out that that area is about 37.962. In part B, we are asked to find the volume of the region R when it is revolved around the x-axis. All right, since this is a volume by revolution, with another solid carved out of it, the function y equals 2 doesn't go all the way down to the x-axis, so we're going to be carving something out of this. We can think of this as one volume minus another volume. And oftentimes, it's helpful to think of it that way instead of trying to piece together one integral that takes into account every little thing. Sometimes it's just easier to say it's going to be this giant area minus this other giant area. All right, so the volume of that solid would be, using the formula for volume of revolution, pi times the integral from negative 3 to 3 of 20 over 1 plus x squared squared, minus pi times the integral from negative 3 to 3 of 2 squared. Just sometimes I think it helps to think of it as two separate integrals. It's a calculator active question, so I wouldn't bother trying to do this by hand. That would be I think a huge waste of time, although perhaps gratifying if you enjoy doing that stuff by hand. But it is a time test, so maybe you don't want to do that. It turns out that the volume of that solid would be 1,871.190. And in part C, we are asked to determine the volume of a solid whose cross sections taken perpendicular to the x-axis are semicircles. The diameter of one of those semicircles for some value of x between negative 3 and 3 would be 20 over 1 plus c squared minus 2. That's just the difference between the two functions. That would be the diameter. The radius would then just be half of that, which would be 10 over 1 plus c squared minus 1. And now we can think of this as basically just integrating some volume of circle cross sections. So the area of the semicircular cross-section would be, well, I have my radius, which is 10 over 1 plus c squared minus 1. I have to square that. Multiply it by pi. That would get me the area of a full circle, though, and I don't want that. So I'm going to divide by 2 again, and we get the area is pi halves times our radius expression squared. So I just need to integrate that from negative 3 to 3, so the volume would be pi halves times the integral from negative 3 to 3 of 10 over 1 plus x squared minus 1 squared dx. And again, this is a calculator active question. I would not bother trying to do this by hand. Turns out it's 174.268. Use your calculator to get that. Move on.